Unit 1, Part 3. So we're first going to discuss physical properties of matter, physical properties, and then chemical properties. So what are properties? Properties are defined as characteristics which allows us to distinguish one kind of matter from another kind of matter. And if you look at physical properties, so number 15, are properties that can be observed without altering the identity of a material. So examples of physical properties include color, size, temperature, density, weight, boiling point, melting point, and vapor pressure. So what do you mean by saying that we can observe them without altering them? If I want to measure the density of an object, it doesn't matter the size of the object, how much of it I'm measuring. I'm always going to have the same density. And I'm not going to change. I can observe it, but I don't need to make any change to it. Physical change, any change in the properties of matter that does not result in a change in its identity. So we can change the vapor pressure of an object by heating up or cooling it down, for instance. We can change the temperature of it, adding heat, taking heat away. We can change the size, and we can also change the color of an object. Changes of state. So changes of state, and there's three common states of matter that we're going to talk about. Those states of matter are physical properties, and we can change them something from a gas to a liquid, for instance, and that would be a physical change. It's not changing it doesn't change the identity of the chemical. It's always going to be the same if I heat something up to boiling point or cool it down to its freezing point. So if you look at freezing, a change of a liquid into a solid that results from the loss of energy heat so that atoms are held together by bonds and are not able to move. They'll vibrate, but they're not moving from one place to another. And boiling, change of a liquid into a gas that results from enough heat being added to matter so that atoms vibrate so much that the bonds no longer hold them together and they move freely and randomly. So if we look at the two of these, freezing and boiling, so if I'm going to freeze something, I'm changing it into a solid. If I'm boiling something, I'm changing it into a gas. Okay, and if I look at the amount of heat that's in these two objects, or the amount of energy, kinetic energy specifically, and kinetic energy is the energy of motion. Gases have the most energy, and solid has the least energy. And actually, what I can do, we can think of an example. If you're boiling water, in order to boil water, you put on the stove. And if it's a gas stove, you need to turn on the gas and light it up. And you're actually adding heat to the water. As the molecules move faster and faster, they'll be converted from a liquid to a gas. And the bubbles that you see, let's say this is a pan of water, you start seeing the bubbles in here in the water. Right? You have heat that's adding a fire over here that's adding heat to the water. You have boiling. They go to the top and they're released. That's actually water vapor. That's water in a gas state that's in these bubbles. It's not actually air. Okay. Now, contrast that with chemical properties. So chemical properties refer to the ability of a substance to undergo a change that alters its identity. In other words, you change it from one substance to another. Examples of chemical properties are the conditions under which paper burns and iron nails rust in the presence of water. We can also say that in order to observe a chemical property, the identity of the chemical must change, as well as some or all of its characteristics. Paper that burns no longer looks like paper, since that results in burning paper as mostly water, carbon dioxide, heat, and light. So after it burns, you can't write on paper. It's not the same anymore. You are left with a lot of times ash, and the ash probably is made up of carbon, but also other substances that are in paper that are not burnable, that won't burn. A chemical change or chemical reaction is a change in one or more substances that are converted into one or more other substances. The characteristics of substances produced are not the same as the starting substance or substances. And in a chemical change or chemical reaction, you have reactants and products. So the reactants, they're one or more substances that undergo a chemical change. Products are one or more substances that result from a chemical reaction. So if you look at a chemical reaction, let's say we have A plus B. So these are two chemicals. And this arrow shows the direction of a chemical reaction. Let's say it makes C. A plus B, C. These are the reactants on this side of the reaction, and this is the product. And the arrow shows the direction of the reaction. So example, paper burning, which produces water vapor, carbon dioxide, light, and heat. And paper would be the reactant, and carbon dioxide and water would be products. Light and heat are types of energy and would not be either a product or reactant because it's energy. So how do you know that a chemical reaction or a chemical change occurs? So there's one or more indications that happen when a chemical reaction occurs. So some evidence that a chemical reaction has occurred. One of them is the evolution of heat and light. So again, I go back to burning paper. When paper burns, and paper really is made up of the same substance as wood, it's cellulose. When it burns, you can feel heat and you can see light that's generated from it. In addition, some chemical reactions produce gas. So B20, production of a gas. So example of that is when you put baking soda and vinegar, mix them together, you'll start seeing a bunch of bubbles generating. That's an indication that that's a chemical reaction. Now, not all changes that you see where there's a gas being produced is a chemical reaction, but a great deal of them are. So example, boiling water produces a gas, but that's not a chemical change, that's a physical change. So some of them do and some of them don't. Formation of a precipitate. So if you look at a chemical reaction that occurs when there's a precipitate, what you'll see is a solid substance that's produced, and either it falls to the bottom or it rises to the top. So if you take two or more chemicals that are liquid state, you mix them together, you actually start seeing some solid material being produced, and that would be an example of a precipitate. Now, when chemical reactions occur, they can either produce heat or absorb heat. So 21, an exothermic change, that's a reaction or a change that releases heat. Again, burning paper is an example. That's going to release heat. But also, when steam, which is water in a gas state, is converted from a gas to a liquid, it releases heat. So that'd be exothermic. And that's something that's important in storms. So if you think of, like, recently we've had hurricanes, a great deal of the energy that's being released is when the water vapor in the air is converted from a gas to a liquid, and that releases heat, which creates or causes the air to rise, and that's where a lot of the energy is from. Endothermic is a reaction or change that absorbs heat as it occurs. So an ice pack containing ammonium nitrate and water, that undergoes an endothermic reaction. So when the ammonium nitrate dissolves in the water, it feels cold, and it feels cold because it's actually absorbing heat. And so anything that feels cold is something that's absorbing heat. It may not be a chemical change, but it's showing that there's energy being absorbed. Another example of this is when you boil water or convert water from a liquid state to a gas state. That's also an example of an endothermic change. Now we can classify matter, and we can classify either a mixture or a pure substance. If you look at mixtures, so a mixture is a combination of two or more kinds of matter, each of which retains its own composition and properties. And you can separate them. And so, an example in a mixture, a mixture could be a heterogeneous mixture. And this is where it's not the same throughout the mixture. So, an example I like to use is if you think of alphabet soup, anytime you take a spoonful out of the, let's say the can or the cup or bowl of soup, it's going to have different letters in it. So that's really showing that the composition is not the same throughout. Where a homogeneous mixture is a mixture which a composition is always the same throughout that solution. So a mixture of salt and water is an example of homogeneous mixture. So when you dissolve salt into the water, you can't see it. Actually, it's because what happens is the sodium and chloride ions, they separate because salt is sodium chloride, and they'll evenly disperse throughout that mixture. And it's homogeneous. No matter, after you mix it up fully, no matter what part of that solution you are going to actually examine, it's going to have the same amount of salt and water. So its composition is going to be the same. So number 26, I'm going to continue on part 4.